we've seen a lot of presentation during these days about voting, wanting to integrate more people into the entire democratic process. Sorry, I need just to take track of time. And we've seen a lot of different perspective about this. And a lot of the things that people have mentioned is that we want to involve people more, maybe make them vote more, or involve them more into this decision process. Something that was not discussed too much is also that this is also coming from a problem. And the problem is that in many democracies, people are losing trust that they can have an impact on the system. And so this is also why we need a lot more of involvement. And in general, I will make it simple, but there are quite a lot of compromises that we need to take care of. And probably the three most important ones are the number of people, because if we want something to go, for example, national scale, we want to involve a relatively big number of people. We want little time commitment, because if we want people to participate, we want them to participate for relatively little time. We don't want people to have spent their life on, making decisions for our country. And also we want relatively big freedom and also the ability of having an impact on the final product. So for example, at the moment, people can express their opinion on social media, but they still feel like they cannot have an impact on national laws and these kind of things, because still there is quite a lot of steps in between that can filter out their ideas and their opinions. And I want to give you three very quick examples of how we can try to solve these problems, but every time we need to compromise on something. So voting, what we saw is it can involve massive amount of people. You can have it at national scale. It's not really a big problem. Well, it's complex, but it's doable on national scale. It involves relatively little time per person. So the people participating do not need to spend, days in the process. They just need to vote and express something. But it also takes away a lot of the power of expression. So people can just say yes, no, or just I prefer this candidate over this other candidate, but they cannot say much more. Another dramatically different example is deliberation, and usually or just people discussing in a room. So in this case, you can have that people can have very little time because maybe the discussion can be over in a few hours. A lot of freedom because you can completely steer and craft the solution that you want, and you can steer the conversation, but you have very limited number of people. And indeed, if we try to scale it up, we get to the other extreme, which is having a lot of people, having a lot of freedom, but having very little time. So if you give 1 minute per person, for example, if you have 10 people, you will get 10 minutes. If you have thousands of people, you are in the range of weeks. If you have in the range of millions of people, you are in the range of years, which clearly is not doable. And as I mentioned, there are many other examples which try to compromise in many different ways. So maybe introducing multi-phase voting, or maybe having like just a city level instead of national level, etc. I'm not going to discuss much about all these methodologies. What I'm going to discuss about is that with Derek, at a certain point, and by the way, there are also many other people which are involved with the project, for example, Damien, we were thinking of, could we have a system that is completely flat, is completely horizontal, and that eventually, in which people can contribute as much as they want, and that can scale up to eventually national level without collapsing. And there is something quite interesting that already exists that is not perfect, but is already going in the right direction. And is a thing called remixing, and is a peer production process. So it's a way in which people can produce something coming all together. I see some people smiling. And something that is quite famous nowadays is TikTok, being banned, unbanned, etc. And something that happens on TikTok is that somebody can upload a video, for example, a video of a funny cat, and then somebody can take this video and just record some music and put the music on the video. And then you have another person taking this second video and making another change. What is interesting here is that every contributors spend relatively little time on producing the new thing. But at the end of the process, you can have something which is also very complex and had the contribution of a lot of people without everyone having to spend the entire time on producing whatever they're producing. So for example, one of the examples here is a song which involves 16 people, but these 16 people didn't go into a room, decided what to play, etc. Everyone just contributed to one part. And there are many other examples, like there is Wikipedia, there is GitHub, and everyone is using different ways to do this. So eventually what we can have is a system where somebody can produce an idea or a design for whatever they want to produce, and then people can take this idea, copy it in a non-destructive way, and generate a new version. And you can keep going and going, and then you can keep branching of these ideas. This is just classical remixing. The problem we are facing with our project is that you also need to select one. We have also another version of the project where eventually you can have multiple winning projects. But if you want something at national level, many times you want just one solution. So imagine you want to propose a new law, maybe on gun control. You cannot have that if you don't like guns, you don't have a gun, and people who have guns, they hold a gun, because that's completely defeating the purpose of having the law. So we need some way then to select what is the best, whatever the best solution means. And the way we are studying this is through analytical models and agent-based models. And we actually developed multiple agent-based models for this. And the reason, I think there was a question before, which was like, if you choose some way your own parameters, you can get some very specific result. So in order to avoid this problem, we are generating multiple agent-based model. Each one is different, but they're still modeling the same scenario, just with different properties. And so at the end, we obtain pretty much the same result in all the agent-based models, even if each one uses a different methodology. What time is it? Okay. The agent-based model, I'm not going to explain all the agent-based models because it will take like 2 hours. I will explain just the simplest one. In these models, we have agents, of course, and we have the solutions. So these are the different solutions that people can produce. For simplicity, we suppose that there is a solution space that can be just an n-dimensional space. Here is 2-dimensional. And people have a utility function which is defined on this solution space. So for each solution, people can tell you how much they like or they dislike the solution. This is one of the main assumptions across all the models. The utility function is fixed in time. So people cannot change their preferences, and they know what they like and what they don't like. Eventually, this is one of the hard assumptions of the models. The other important thing is that the utility functions are personal. So everybody has a different utility function, but we also have a global utility function, which is just the average of everybody's utility. And the other important thing is that we have a platform, which is where people can store their solutions or these designs. And also people they do not know all the possible solutions, because of course there would be cheating if they know exactly all the possible solutions and they just select whatever they like the most. This would be not a very realistic representation. So how does the model work then? Well, we have the platform, and there are some solutions already stored on the platform. We initialize with just one solution. And at each iteration, an agent takes one solution from the platform and they estimate how much they like it, so for the utility function, and they look for the possible neighboring solutions. And they also estimate how much they would like it. And if there is a new solution that they like more than the others, then they add this on the platform. So this is only if they like it more. And what is important here is that we are assuming that agents are kind of self-interested. And we're doing for two reasons. First of all, because it makes the model simpler, because otherwise we will have another parameter, which is like how much they care about everybody else. And also because it's a kind of worst case scenario. So we want to see if even in a case in which everybody is just thinking about themselves, we can still have that people can produce pretty good results at the end. And in a moment, you will see also we are using some kind of comparison model, which is inspired by deliberation. And in this model, we have that all the agents come together and they directly select what is the best global for all together. So they still do the exploration, but instead of maximizing their personal maximum, they maximize the global maximum. So they try to explore the global utility function. The results are this, and the dashed line is the one from our model, from remixing, and the solid line is the one from the deliberation model. And on the x-axis, you have the time per person. So how much time every person should spend on producing something new. Something that you can notice immediately is that our model grows logarithmically in time, and the deliberation model grows linearly in time. So the simplest thing to say would be like, well, the deliberation model in the long term is better. So that's definitely a win for this model. But the problem is that what we are discussing in the first place is that we don't want people to spend years of their lives to design something new. We want people to spend very little time on producing these new ideas. So actually, even if in the long term, this model eventually would be better, we still want to analyze everything in the short range to have something which is feasible for people. By the way, this is like just how much time per person, but we don't know how much time is in the real world. So this is not in seconds or hours. This is just a unit of time we defined. The other important thing that we noticed is that the deliberation model scale inversely with the number of people. This means the more people you have, the longer it takes to move to the next step, because all the people need to discuss and decide what is the best for everybody. Our model does the opposite. Our model grows together with the number of people. The more people you have, the more computational power, and so the better the results that they are able to find. And so we have that in the short range, this model does not just work better, but it even scales in the right way. So if you go on national level, it would be even better. Now, there is one big problem with all of this that I haven't discussed yet. And by the way, this is also with the analytical model. The problem is that so far, we just selected the best result in the pool. So people produce a lot of solutions. And then what I showed you here, I can go back. So what I showed you here is just selecting what is the best solution in the entire pool. But the problem is that in general, we cannot do this in real life unless we suppose like some artificial intelligence which explores all this solution and just picks up the best. So the alternative would be eventually to have that every solution need to be voted by everybody else. This, of course, means that we completely destroyed the gain that we had before, because before we had that everybody can just work on a little part, but now they have to vote on everything. So this takes a massive amount of time. We don't have yet that for the moment. An alternative, and I'm going to give you like just the rough idea, is, by the way, if we plug it into the model, we see that it doesn't scale in the right way anymore. What we can do then is that we can eventually have that every solution is voted by just a subset of people. So a relatively limited number of people. And we do this for every solution. And if we do something like this, then we have that our model scales again proportionally with the number of people. So we have again that the more people, the better the model. Now we put this in the model, and you can see here, I'm going to explain the other one in a moment. But here, what we're seeing is like, if every solution is voted, for example, by 10 people, and we just select the one which got the best vote, how far is this one from the best possible on the platform? So we took the utility of the best one, and we compare with the utility of the one which has been decided by the people. And we have that already for 10 votes, this works very well. So people still are able to choose very good results. What time is it? Okay. Of course, this creates a big problem because eventually you will have that something arrives a national law, we make like a national decision, which has been decided just by 10 people. And I don't know you, but to me, this doesn't look too legitimate. So what we can do eventually is to introduce like a multi-phase system. And in this system, what you can have is that initially you have like all the solutions, and the solutions are just voted by a small amount of people. And then you can select like the 100 best and go to a second phase. The second phase, they're voted by more people, and you can repeat this multiple times. For simplicity here, we just did a two-phase step in which we select initially, like everything is voted by, let's say, 10 people, and then the ones which reach the top 10 are voted by everyone. So at the end, what is selected has been voted by everyone. And in this case, we have that the curves actually work even better. So we reach even higher values, even if people need to vote a little more. So, as I mentioned, we tested also with many different models. We also tested within the same model by changing the relationship between how people express, like how they vote, respect to the utility function, because initially we suggested like a linear behavior, but we tested also quadratic behavior, sigmoid behavior, and they pretty much all show very similar results. So the more people we have, the better results we get. The only one which doesn't perform well is an inverse sigmoid, which is like people vote, pretty much they give close to 10 to everything below 8, and they give close to 0 to everything which is above 8. So this would be like they try to sabotage the system. So of course, if everybody tries to sabotage the system doesn't work anymore. But all the other, they work pretty well. So this is pretty much it. Just let me summarize again. What we have here is that we studied this system only with models and simulations. But what we showed is that eventually it's theoretically possible to have a system that scales with the number of people. So the more people we have, the more powerful the system becomes. This is pretty much the opposite of what most of the other systems have to do, because in many of the other systems, the more people you have, the more complex and the more messy the system becomes. So this is it, and I'm open to questions. So thank you very much.